Hey, Chemsters, this is Mrs. Vanderlei bringing you the last video of this entire organic semester. Woohoo! All right, something to celebrate, I know. So the last video we talked about amides. This video we're going to talk about amines. Remember how I told you that these are cousins of one another? And if you look back at the functional groups, I had you memorize what's the difference between a carboxylic acid and an ester. Those cousins, you take off an H, you put in a carbon. What about alcohols and ethers? You take off the H of the alcohol and you put a carbon in for your ether, okay? Your butanol, your aldehyde and your ketone, same idea, okay? But what makes amines and amides cousins? Amines do not have that C double bond O. Amines are attached to just a regular carbon, okay? And that's your key difference between amines and amides, okay? So as far as classification goes, I would not call this an amine. This is just plain old ammonia, okay? So a primary amine, all right, has a carbon, one carbon to it, and that's important. A secondary amine has, take a wild guess, two carbons attached to it. All right, and a tertiary amine has three carbons attached to it. Again, this is so important that you know this distinction, okay? A primary amine, all amines are going to have at least, and this is important, I'm going to jot this down, all true amines are going to have at least one carbon attached to the nitrogen. And that's going to be really important when we talk about nomenclature, okay? So next we have some secondary and tertiary amines, be actually part of a ring, okay? So isn't that kind of cool? That's pretty nifty, all right? That would be a secondary. Why? Because there's one carbon here and one carbon there, all right? Only two carbons making it secondary. Well, guess what? This one is a tertiary. Why? Because it has one, two, three carbons attached to it, okay? Let's go on to the next page. So problem number one, classify each of the following as a primary, secondary, or tertiary amine or amide. Guys, fix this one for me. This is supposed to be benzanamide because it's N, C double bond O, and from there on, okay? So go ahead and label each as a primary, secondary, tertiary, and when you get to nicotine, there's two nitrogens, so you should have two distinctions, okay? I'll pause this, or you pause this, and go for it. All right, welcome back. I did not draw this structure out, but I think you can see, look at your nitrogen. How many carbons are attached to it? One, it's primary. What about nicotine? You got two of them. So let's look at this nitrogen. How many carbons are on this nitrogen? There are three of them. All right, how many carbons are attached to this one? Two of them. So you're telling me that nitrogen can be part of like a ringed structure, almost like an aromatic? And the answer is yes, it can. All right. Notice there will be no lone pairs on this nitrogen. I'm sorry. You have one lone pair. My mistake. And you have one lone pair here. Okay. So you always have three bonds on nitrogen unless it's an ion like ammonia. Okay. So what about p-methylbenzanamide? All right. What kind of nitrogen is this going to be? Well, how many carbons are attached to that nitrogen? Only one. So that would be a primary amide. And what about this one? Dimethylaminocyclohexane. Okay. And there you go. Now, let me just tell you something. This is the common way of naming that. So when we get done talking about nomenclature, I'll show you what the IUPAC name of this same structure would be, okay? So do me a favor and make this IUPAC. I made a mistake when I made the notes, but I fixed them now. I decided for my sanity and yours not to really talk about the common name. The IUPAC is enough, okay? I'll just also kind of give you a clue. I went back and I looked at my old college textbooks because this wasn't what I remembered. And by the way, the 1978, I think, edition of Morrison and Boyd, which I had, so it's in the 70s. My goodness, that's like 40 plus years ago, wasn't it? Yes, it was. When that book came out, they used the common names. So I'm trying to be consistent and not to mix what I learned originally with the IUPAC nomenclature, okay? So I'm going to do my best. So what this is the IUPAC. So you're going to add the suffix amine to that base name, okay? So look right here. This would be ethanamine. All right, let's scroll down a little bit. This is the IUPAC name. I'll just put them all there. All right. So you have ethan, and then you just add amine, ethanamine. So this would be 2-butanamine. Notice that you have the amine group off the second carbon of the butane group. And here, this is the third carbon off of the pentane group. Okay. So this is actually letter A is actually again the IUPAC. Okay, so make note, this is, I flip-flop these two. I did check this out. I even went on the web just to make sure I was right. Okay, so the IUPAC, the N is going to tell you what the R group is on the secondary or tertiary amine. So the point here is, watch, is that I have, in this case, it is a, well, what is it? Is it primary, secondary, tertiary? This is a secondary. So it's a secondary, like I just said. And what does that mean? You have 2 carbons attached to it. So how you name this is that your longest carbon chain, okay, in this case I have 2 carbons. So it becomes an ethylamine. But my second carbon is attached to the nitrogen, correct? And it's a methyl group. So I have one other carbon attached to the nitrogen. So the ethylamine tells me my longest chain of one of the carbons attached to the nitrogen. I have a second carbon attached to the nitrogen, so it becomes N-methyl ethylamine. So one nitrogen, one N, means I have a total of 2 carbons attached to it. One's a methyl, the other one's an ethyl. So let's look at this one. All right, it's a tertiary. So what you need to do is determine which is my longest chain. Here's my nitrogen right here. I have a methyl, I have an ethyl, I have a propyl. So what's my longest chain? I hope you recognize it is propyl. So the name here is N, N. Why? Because it's tertiary. I have a total of 3 carbons off of the nitrogen. The word propyl is my longest chain. So because it's an amine, it has to have at least 1. But I have 2 other carbon groups here. And so I need to have 2 N's written here. So it becomes NN ethylmethyl propylamine. Why is it ethylmethyl? That's your alphabet. All right, so here's this structure. Once again, it is tertiary. So how many N's are going to be written out in front? 2. All right, so this is my longest chain. That's your cyclohexane. So it becomes N, N diethyl cyclohexylamine. Okay, so how will we name this? This is your common name. What's the IUPAC name? Take a minute out and figure it out yourself. Well, hopefully you got N-N-dimethyl cyclohexylamine. All right, so there you go. Let's go on to the next page. Okay, so now what? My longest chain is 5, and I have 1 other, so I need 1 N on this, right? So I have a methyl group on the nitrogen, but where is my nitrogen? It's on the, not on the first carbon, it's on the second carbon of the 5. So it becomes N-methyl, which tells you I have a carbon group on the nitrogen. And then where is this methyl group on carbon number 2? So 2-pentanamine. So take a wild stab at how you're going to name this one. All right, I got this, N, N dimethyl 3-hexanamine. All right, why is it NN? Because I have 2 carbon groups besides the longest chain on the nitrogen, and they're both methyl groups, so it's NN dimethyl. Well, where is this? Well, it's on the 3rd carbon of a 6 carbon chain. Now, I've already alluded to the fact that if you have other functional groups present, then the amino group is named as a substituent. All right, so it's not going to end in amine anymore. It's going to end in the higher priority of the functional groups. So what do you notice in the first one? What functional group would have 2 oxygens and a hydrogen? Isn't that a carboxylic acid? So how many carbons are in my carboxylic acid? I got 1, 2, 3, 4. Well, that's a butanoic acid. So where is my amine group? It's on carbon, excuse me, number 1, 2, 3. So it's 3 amino butanoic acid. Now, what do you notice here? This functional group is a ketone. Well, that has a whole lot higher priority than an amine group. Okay, so you'll see I numbered it 1, 2. I had to make my ketone on the lowest numbered carbon. So 2, 3, 4, 5. So this is a pentanone, isn't it? And notice how I did this. It's a 2-pentanone because that's where the ketone functional group is. And then my amino is on the last carbon. So it's 5 amino 2-pentanone. Now, what about this next one? This is not a primary. All right, this is a secondary amino group, right? So look what I had to do here. I apologize. It is not a ketone. Mrs. Vanderwall, I tricked myself, all right? So I have a C double bond O directly attached to a nitrogen. That's not a ketone, folks. That's an amide. All right, so let's take a look at what I came up with. All right, here it is. I have a 2-hydroxy. This is an alcohol group, all right? It takes a lower priority than a carboxylic acid derivative, which an amide is. So the amide takes a higher priority than the alcohol. I'll say that again. The amide takes a higher priority than the alcohol because the amide is a derivative of the carboxylic acid. So here's my carbon number 1, which is my amide part, all right? So the OH group is off of the second, that's why it's 2-hydroxy, and then what? I have an amide. Well, I have a secondary amide, so I have a N-methyl ethanamide. Woo! All right, aren't you glad you don't finally exam over this stuff? Let's keep going. So you might recognize when you have an aromatic with a NH2 group hanging off it as an aniline. All right, so aromatics are derivatives, are named as derivatives of aniline. So this is your straight aniline. So this would be, hopefully you got this, a p-bromoaniline or 4-bromoaniline, take your pick. Now what about this one? This is still a tertiary nitrogen. So what does that mean? You still need to put the N group in there, right? You need 2 N's. So you have N dimethyl aniline, okay? So what would this one be? All right, holy cow. This would be a N, 3 dimethylaniline. So if I have a methyl group off the nitrogen and a methyl group off the aniline, that's how this is named. All right, N, 3. They're coming off of both. You have a methyl group coming off of the aniline, and you have a methyl group coming off of the N here. Okay, so N, 3. So what I did, this is probably not on your notes. I thought, okay, let me help clarify it. So what if I have 2 different things here? They're not both methyl groups. I made this methyl, I made that ethyl. So how does that work? I wrote 3-ethyl, or you could use M if you wanted for meta. But I thought an M and an N, I just stuck with numbers to be, to me, less confusing. If I get MNOPs, you know, what the heck. So I have a 3-ethyl N-methyl aniline. Okay, so maybe that clarifies what's going on here. So take a look at these 2 closely. All right, this structure, and see, you know, in your mind how they are named, okay? All right, last but not least, I think this is a huge, important thing. I really do like covering this last. Why is that? Well, it ties so well into a lot of things that we talk about. And those of you who want to go into biology, this is huge, okay? I want to talk about amino acids. The intro is proteins are naturally occurring polymers of what? Amino acid units, I should say units, joined together by an amide. Spider webs, animal hair, your hair, muscle, egg whites are all proteins. So just like the name implies, an amino acid contains both the amine and the carboxylic acid group. So here is one of the basic amino acids you could have. Now, why did I need this carbon here? If I left it out, then I would have like an amide, but that would not be an amino acid, all right? So notice that this nitrogen has to be with a singleton carbon, just like what we've been talking about up here. It's not its cousin. There's no C double bond O off of the nitrogen that makes it an amine, and then this carbon is your carboxylic acid. So this is the most basic amino acid you could have. Well, let's check this out. So how does this work? Here's my amino acid, and here is another amino acid. Why did I line them up this way? Well, again, it's not as easy as it looks. The mechanism is more complicated, but I'll let your college professor worry about that. But what do you notice? If you can make water, you will make water. So what do I make? Well, I make water. So get rid of the OH and the H and then push them together. And this is what I got when I pushed them together. And what, voila, do you notice? The N here is now hooked up to the C here. And let me do that real quick. Do you see what happens? I made a peptide linkage. Why do you think they call it peptide linkage? What does it end in? It ends in "ide." Why? Because this is an amide, isn't it? All right. So I just threw in some examples. All right. This may start looking like a biology class. So there are dipeptides. Now it sounds like a dipeptide has two peptide linkages. Actually, no. A dipeptide has two amino acids put together. So it has one peptide linkage, but it has two original amino acids. So you might recognize this is a what? Glycine. Oh, must have an amine here, all right? And this is your aniline. All right, or aniline, there we go. And then here's this. And when you put them together, what do you get? This may look familiar. All right. Now, what else did I do? Here's a tripeptide. Well, a tripeptide has two peptide linkages. Here's one, and here's the other. But I've used three different amino acids. So you might want to abbreviate this as ALA-GLY-SER, okay? And then what? Here are your polypeptides. Well, I should make this smaller, hang on. So here's a polypeptide. These are your proteins, okay? The molecular weights can be up to 10,000 grams per mole. These are huge. All right, and notice they have it nicely color coordinated. These are all the possible different amino acids that can be hooked together that could make your protein. Now, let's just talk real quick. Why is this important? Well, you know what? This right here is an example of why some people have curly hair and some people have straight hair. Huh? All right, it's hydrogen bonding of these side groups that determine whether you have curly hair or straight hair. Okay, so there's so much to do with this. It's pretty amazing. It really is. So I will give biology some kudos here because I think this is very fascinating on why we are all so different. Think of all the different combinations your DNA can be hooked together using the basic amino acid. So I'm going to leave you that to ponder. What makes you so unique? It's this, all right? And I'm glad you are. So don't wait to be great. I hope to see you sometime. All right, take care. Bye-bye.